of the session itself.
Recording is on.
So let me first take you through an overview of blockchain technology. So if you actually go to Google and you search up the word blockchain, and if you see the Wikipedia article and see how exactly Wikipedia defines this term blockchain technology, you'll find that this is what it says. So basically, in the internet, they say that blockchain is basically an open or decentralized ledger that can effectively record transactions between two parties, and it can be done so in a verifiable, permanent way. So what does this mean, right? So that's something that we're going to explore in the rest of the session. What this complicated sentence means. In reality, is actually quite simple, and the underlying technology, the concepts, all of that is very easy to grasp. So you'll learn at the end of this workshop that this basically means something very simple, but yet very powerful. So that's so, and also if you look up the word blockchain, some of the other words that commonly pop up are open, distributed, safe, secure, permanent. So what these terms actually mean in the blockchain context is something that we're going to explore in the subsequent sections. So let me first start off by saying exactly how transactions are recorded in a blockchain. So what is a blockchain? So simply put, you can think of blockchain as a highly distributed database. So what is the purpose of a database? A database is something that can basically store data, something that you can write data on, and something that you can retrieve data from. And so that's effectively what a blockchain is, except it's a much more distributed database, and the access is more democratic. So here are the various steps in which you can actually write data onto a blockchain. So in the blockchain context, we generally refer to the act of recording data into the blockchain as recording a transaction, or verifying a transaction. So here, that's one thing I'd like you to know. The transaction can basically represent any data that is to be recorded into a blockchain. So here are the various steps in which one can do so. So the first step is when a user actually requests for a transaction. So he requests for certain data to be written onto the blockchain. As a second step, a list of all transactions is now collectively represented as a block, and now this block is created. So suppose you have, say, 50 or 60 transactions that you'd like to record. Instead of simply verifying one transaction at a time, they say, okay, let me combine all of them to form what is known as a block, and let me instead verify this block. And now, how traditional payment processors or how traditional systems work are that there are generally only one person that gets to decide exactly, what data gets written onto the database, and what gets registered. But that's not so in the blockchain context. So you need to seek validation, and you need to seek permission from all the participants in the network to write data onto a blockchain. And so that is the third step, where this block of transactions is now publicized to an entire network. So all the participants that actually form this network get to know what this block exactly is and what are the transactions that are recorded in this block. So that is the third step. And the final step is when all participants actually validate the transactions, when all participants say that, okay, I verify that all these transactions are legitimate. I verify that the data that is written, that is being submitted, is something that is accurate and we'd like to write on the blockchain. And when once that process of verification is done, the block gets added into the chain. This is the various steps in which one can actually write data onto a blockchain. You can basically think of blockchain as a highly distributed database. Now, let's talk a little bit more about the key features of blockchain. So I'll be actually deep diving into each of these features: decentralization, immutability, and traceability. I'll actually be covering a lot more than what is there in the slides, but I generally prefer to keep my slides very minimalistic and deep dive into the content on top of what is already being displayed. And so we'll actually be going a lot deeper into each of these three features. So let's talk about decentralization. So the way I cover these three key features is that first I talk a little bit more about some of the terms that you need to be familiar with in order to follow with this conversation. After that, I'll talk about what this term exactly means, and then I'll shed a little more light into the issues that we have, uh, which are associated with this property of blockchain technology. I talk a little bit more about why this property becomes important and how it is achieved in the blockchain context. And I'll also be providing some examples about of which applications actually use this concept of blockchain technology. So that's how I'll basically go through these three key features of blockchain. And so let's start off with the first one. The first one, and probably the most common one, is actually something called decentralization. So what is decentralization? So the property of a system being decentralized is when all power is actually distributed and dispersed away from a central authority. So most, if you look at most financial as well as government systems today, they are highly centralized in nature. What this means is in such systems there exists a central authority which is actually in charge of maintaining and managing these systems. For example, if you take a look at DBS Payla, right? Suppose you have two people, person A and person B, and suppose person A wants to send say $10 to person B through DBS Payla. So it is actually that centralized authority that is DBS Bank that gets to approve, okay, that this transaction is valid, and that person's A bank account is now this much. Like suppose it was $100 before, now he sent $10, so it's going to be 90. So that process of validation and verification is actually done by a centralized authority in a single person. It is not done by multiple people and multiple nodes in the network. And so that is essentially what decentralization wants to avoid. So basically, decentralization is refers to the dispersion, delegation, or distribution of power away from a centralized authority. So there are actually several forms of decentralizations with varying degrees, and so each one have each level of decentralization in each form has different properties, and we have to consider different trade-offs before actually making a decision on which one is the best. So if you see how decentralization is actually implemented in practice, you can be decentralized in terms of architecture, culture, control, and decision making. So what does architecture refer to? So basically, architecture sets forth the different roles of network participants and how they interact. So a highly decentralized architecture will ensure that all peers have the exact same role and thus exert the exact same amount of influence on the network. However, if you look at centralized systems, they would generally give a single peer almost full control of the network, while other participants in the network can actually interact with the network in very limited ways. So this actually also affects to a great degree the consensus protocols that are used in various blockchain systems. What are consensus protocols is something that we'll be studying soon also. Now let's move on to culture. So what does culture mean exactly? So culture actually defines the social norms of the people that interact with the network. So if you take a look at a technology ecosystem, the culture and the interactions could actually be in terms of developers that want to build software on the network. So you have like a network and people would like to build certain applications, some software applications on that network itself. So that can be one way in which there is interaction with the network. Another way in which there is interaction with the network are through researchers who basically would like to investigate the potential and pitfalls of the network. And so interactions can basically also mean anyone who has a stake in it. So even a simple node and a simple participant in the Bitcoin network who wishes to mine some Bitcoin, they themselves, so that interaction with the network also comes under this category of culture. So one more thing about decentralization is that decentralization can also be achieved through culture. Another way in which we can have some amount of degree of decentralization is in control. So control of the network can be done in several ways, but it ultimately boils down and results to the governing of the network's participants. And when I say governing of network participants, This could involve basically legal structures as to how the network is funded, the amount of changes each peer can basically make on the network itself. So that is what I refer to when I say control. And finally, a system can also be decentralized in terms of the decision making process. The decision making processes basically determine the growth of each network, and it also helps in weighing the trade offs that need to be taken. So, as blockchain technology is relatively new and there are challenges which are unsolved and unforeseen, having a very robust decision making process is actually important to ensure that the network can evolve and adapt to each challenge, be it a social challenge of people wanting to adopt the technology, or even a technical challenge that needs to be overcome and a hurdle that needs to be crossed for the network to scale. So this concept of decentralization is actually fundamental to blockchain technology, and this is the key value proposition for most of the use cases of blockchain today. So decentralization can be viewed from a blockchain perspective as a mechanism that provides a way to remodel existing applications and paradigms or build new applications in order to give full control to the users. That is the key point that I like to drive home, where decentralization gives full control to all its users. So there are today, if we take a step back and see how well such a solution is being, accepted or used in the industry today, there are actually very conflicting ideas on the importance of decentralization. But one thing that everyone can basically agree upon is that it completely removes the need for trust when more than one party comes together to collaborate. So this actually gives rise to new types of goods and services which are still untested and still need to be evaluated. But the right now the potential for such applications seem very promising. Now, what are some of the issues that you face when you actually would like to implement decentralization on a blockchain network? The first and most common issue is the issue of scaling. So what is the issue of scaling? So there are actually many challenges in keeping a network decentralized. One actually intends to grow the network and include more number of participants. So it makes sense, right? Like suppose you have a network of say 5 people, having all 5 people come to the same page or agree at certain decisions or come together for consensus is actually much easier than if you say have 20 people, 30 people, 40 people, or so on. So as in when your network grows, it becomes very hard to involve everyone in making decisions that pertain to the network. And so that is a key problem that actually plagued, even very common networks such as the Ethereum network. So how many of you are familiar with the Ethereum network? So Ethereum is actually the second largest cryptocurrency by market. So this is actually something that plagued the Ethereum network, and the common problem was seen through transaction speeds. So the transaction speeds used to be very large, as in when the network started to grow and include more participants, because it became very hard to reach consensus. For everyone in the network to reach consensus. So some of the solutions that was actually proposed to address this issue of scaling is the lowering the level of decentralization, which could be a trade-off for faster transactions. But this actually fundamentally lowers the level of security of the network, as this increases the need for trusted parties. So that is one common issue that is, that we face when we try to implement decentralization in the blockchain network itself. Another issue is the issue of economics. So as and when a network grows, one can actually not predict how its peers might interact when utilizing the resources that the network itself provides. So what do I mean by this? And one of the common example that we see, which is the issue that is being broadcasted in real life. So the common issue that we can see when we talk about economics is the issue of mining pools or centralized mining exchanges. So even though the blockchain network is meant to be decentralized, you can have many peers and many participants coming together to collectively mine on the network. And so this has actually led to high levels of centralization in the network, which is done through something that is known as mining pools. So these are the two main challenges that are faced by anyone who would like to implement decentralization in real life. Now, we should take a step back and ask ourselves, why do we need decentralization? What is the purpose that decentralization actually serves? So the first point is that it actually allows for greater participation between non-trusted parties. So we just spoke about how when we have a decentralized system, the need for trust is completely removed from the network, as you don't have any middleman anymore. As you have, as all the controls is actually given to the user, there is no need of trust between parties. The second reason is that there is better reliability in your network, as you do not actually rely directly on centralized intermediaries. So these are the two main reasons why we would like decentralization to be implemented in real life systems. How is decentralization achieved? So in the Bitcoin network, for example, decentralization is actually achieved in terms of full nodes and light nodes. What is full nodes and what is light nodes is something that I leave up to you to kind of search and research and read up a little bit more about. So that's one thing about this workshop I'd like to highlight here. So there are a lot of things. I'll be laying down the foundations and giving you the basic prerequisite knowledge that is required, but I'll be leaving a lot of things for you to kind of discover on yourself, because I feel that the entire process of self-discovery, of going on to Google, typing up the words, reading a little bit more about what these concepts mean, is very crucial and actually in your learning journey. So I'll leave that up for all of you to read a little bit more about. Okay, so how can you be decentralized in terms of culture? So we are in Asia, right? And what is the key cultural belief of Asia? It is the open source culture, and they are actually high advocates of this entire open source culture. So what is open source itself? Is an ethos that values collaboration on community projects, and so this is another way in which decentralization can actually be achieved in terms of culture. So if we take a look at organizations like Fosatia, the Linux Foundation, so all of these are very successful open source foundations. In fact, if you talk a little bit more about the Linux Foundation, their involvement in the blockchain industry is actually through the Hyperledger project, which is another open source blockchain project. How about control? How can you be decentralized in terms of control? So we know something that's very commonly known as the Ethereum Foundation, which is basically an organization that basically runs and caters more towards the scaling up and the development of the Ethereum network. So it is actually incorporated as a Swiss nonprofit at Zug, Switzerland. I'm not sure if that is the current pronunciation, that Zug, but yeah. And how do you have how does the Ethereum Foundation ensure that everyone has control over the network? So they provide grants that pay teams to actually work on projects that involve the Ethereum network itself. Now, how can you be decentralized in terms of decision making? So a common example is what is known as Ethereum Improvement Proposals, or EIPs. So these are actually standards that specify potential new features or processes for Ethereum. So if you take a look at an EIP should actually contain technical specifications of the proposed chains, and should also act as a source of truth for the entire community to refer to. So, so in Ethereum, all network upgrades and application standards are actually discussed and developed through Ethereum improvement proposals. So this is currently how all decisions pertaining to the Ethereum network are made. The most common EIP that just passed very recently, which has a great impact on the transaction fee market, is actually EIP 1559. That's something that you can also go and read a little bit more about and find out more about yourself. Now let's move on to the which portion of this section. So which applications actually make use of this property of decentralization itself? So we have self-sovereign identities, where users can actually manage their own reputation, data, and digital assets. So ID 2020 actually supports digital identity programs across the world. Another application is the application of decentralized exchanges. So we all know how traditional exchanges work for buying, selling, and trading your financial assets. But you also have something that is known as decentralized exchanges, which require no central coordination between the parties and all participants that would actually like to buy and sell these assets. And so all participants basically interact entirely on the basis of incentives. So this concludes the first section on decentralization. So we spoke a little bit more about what decentralization is, what are the issues that people face while trying to implement decentralization in real life, which are the examples that actually make use of decentralization, and how it's being achieved in various networks, and also why it is important to have a network that is entirely decentralized. So that is the first portion, and that is the first key feature of blockchain technology, decentralization. Let's now talk about a little bit more about the second key feature of blockchain technology, which is the property of immutability. So another few set of terms that you need to be familiar with in order to keep up with this conversation of immutability is number one, what is a fork in a network? So a fork is essentially a change to the protocol or a divergence from the previous version of the blockchain. So let me try and pull up a pictorial representation of what a blockchain fork is for you to understand this a little bit better. Yep, this is essentially what a blockchain fork is. So let's take a look at this picture. So it basically refers to a change to the protocol or a divergence from previous versions of the blockchain. So if you look at previous versions, right, they follow the old rule, they follow the old rule, and so on. But suppose you would like to go back to this block and implement a certain change from the previous version, and also diverge from certain decisions that were made from going from this block to this block, you essentially created a new fork in the network. And in this fork, from from this fork onwards, all these blocks will follow a new set of rules that has been implemented while forking from this point. Yes. So this is blocks from non-upgraded nodes. These are the blocks from upgraded nodes. So this is a pictorial representation of what a hard fork is, or it is a pictorial representation of forking in blockchain in general. Let me go back to my slides. Yeah. So there is one term that you need to be familiar with. Another term is the blockchain explorer. So a blockchain explorer is actually a tool that you can traverse, that you can use to traverse blockchain records. And yeah, so that's something that we will actually play around with also later when talking more about immutability. I will give you the link to actually play around a little with the blockchain Bitcoin blockchain explorer, and then you can just try your hand at seeing all the transactions that was recorded in the Bitcoin protocol. Another term that I'd like to talk about is the term called hashing. So what is the meaning of a hash? A hash is actually a one-way function that generates value from a string of text. So if you look at mathematics, right, what is a function? So a function, suppose you have a function, say f of x, and you give it an input x, you get a certain output. So that is essentially what a function is. You can think of it as a black box that takes in a certain input and gives out a certain output. So that is exactly what a function is. Now, what is a hash? A hash is actually a function which generates values from a string of text, which is pre-image resistant, which means that suppose you have a function h of x, which is known as a hash function, and you're given input x, and it gives an output y. If you know the output y, you cannot guess the input x just by knowing the function in the output y itself. So that is one property of hashing function. So you cannot guess the input from knowing the output. That is exactly the key idea of what a hashing function is. And it is also collision resistant. What is the meaning of collision resistance? Suppose I have two inputs A and B. The hash function will now provide a unique output for each of these inputs A or B. So, which means that there's actually no way in which you can have two inputs that can give the same output on hashing a function. Okay, so that is what a function hash is. I hope all of you are able to follow right now. And another thing that we I'd like you to be familiar with is the meaning of the word fungible. So fungible is basically being something of such a nature that one can part that one part or quantity may be replaced by another part or quantity in paying debt or settling an account. So that is the technical, definition of fungibility. But the main example I can give for fungibility is your currencies. Now, suppose I give you $1 today and you pay me back the debt tomorrow, you need not necessarily give me the same $1 note I gave you. You can give me any $1 note. And so that's currencies are actually fungible in nature. Okay, so that is a little bit more about fungibility. Okay, so that is the terms that I need you to be familiar with in order to keep up with this discussion. And this is the discussion itself. So let's start. Let's talk a little bit more about immutability. So, what is immutability? So through immutability, all transactions in the blockchain is actually made reliable by making it completely unchangeable by any single party. This actually ensures that all activity records and network participation rules are agreed upon and kept until all necessary parties agree to change them. So it's not a single party that can decide how to change these rules, but it's actually all the necessary parties. So what this essentially means is that through immutability, the blockchain has the ability to ensure that the data that is written on it can never be altered. So this is actually makes the blockchain tamper proof. So if you have malicious nodes and malicious participants who would like to come and change the data on this network, they cannot do so. But if you look at traditional databases, through many attacks, it is actually possible to rewrite and change the data that is written on these databases. So it's not completely tamper proof, but a blockchain is 100% tamper proof, and that is the property of immutability. So how is immutability actually achieved? So the structure of the blockchain itself allows for the ability of individuals to independently verify the state of the network. So each peer can basically compute the blockchain record themselves, and they can replicate the changes in the state of the network by themselves. So a malicious peer will basically have to compute the consensus protocol for blocks that have already been mined and outcompete all the miners and broadcast their blocks first to every peer in order to change data that is written in the blockchain. And this is nearly, or I can actually say this is almost 100% impossible unless you have a very hard fork of the network, a hard like the hard fork which I just spoke about in the beginning of this section. So how exactly is this achieved? So basically, what what I just said, right? So this all essentially boils down to the structure of the blockchain itself. So if you didn't understand, in put in simple terms, this is how immutability is actually achieved in the network. So each block in the blockchain is actually cryptographically secured and is given a unique digital signature, which is known as the hash value of the block. Now, any change in the data that has been written on the block or any changes in the transactions that have been recorded on that particular block will change the block's hash value. Now, what is really unique about the blockchain is that the hashing of one chain actually not only uses the data that is written on that block, but actually also uses the metadata from the previous block, which means that any change in the data that has been recorded in the previous block will also alter the hash value of the next block. And that is how you create an unbreakable bond of blocks. And that is how blockchain actually gets its name. It's essentially a chain of blocks. So once the data has been written on the blockchain and all the transaction has been approved and accepted, the data on the blocks can no longer be altered. So this is immutability in a nutshell. Okay, so now what are the issues when it comes to immutability? Let's talk a little bit more about what are some of the challenges that we face when we try to implement immutability. The first chain is, as I mentioned, hard forks. So, rewriting large portions of the blockchain means that the records are not absolutely immutable. So, I just showed you how we can actually deviate from the old rules and follow new rules. So, that is one challenge when it comes to immutability. A second main issue that I'd like to highlight here is the issue of irreversibility. So, which means that suppose wrong actions are actually accepted in the blockchain, and once they have been successfully recorded, these actions can not easily be reversed. So it's not easy for someone to go and undo a mistake that was actually recorded in the blockchain because of the property of immutability. So in fact, vulnerable smart contracts, what are smart contracts is something that we'll talk about later in the session. So it can actually be easily decompiled and exploited. So a very common example of this situation was actually the DAO attacker. So I don't know if you guys are familiar, but there was someone who actually launched a full scale and an attack on the Ethereum network, and this actually caused a loss of $70 million because of this one, this one attack that was launched. And now, because of immutability, it was very hard for anyone to reverse this attack because once the data has been written on the block, it becomes very hard to actually reverse this process. So that is the issue of immutability. Now let's talk about why do we need our blockchain systems to be immutable? Why is there a need for immutability? So the first point is that it sets forth a new paradigm by no longer requiring record keeping intermediaries. So you no longer need a middleman who can actually keep the records for you, but instead the records are entirely on your hand. And they're also tamper proof. And it also once again overcomes the need for trust in record kept, as you can verify the transactions of the block and you can verify the data on the blockchain independently. Okay, but before we continue forward, I'd like you to all to check out a block explorer. Actually, we'll do that in the next section of of traceability. It's okay. Okay, we'll just continue with the session for now. Okay, never mind. Sorry, my bad. Okay, so now let's talk a little bit more about how immutability is achieved in the blockchain context. So if we look at blockchain systems, the transactions are actually verified and are embedded with a timestamp, and these timestamps are basically secured uh, in the form of digital signatures and hashes, which are clearly which I mentioned before. So, like how I mentioned, an unbreakable bond of of blocks or a chain of blocks are formed by involving the data of the previous block or the metadata of the previous block in the hashing process of the next block. So this is basically how immutability is achieved in the blockchain context. So if you take a look at what all we've discussed, that is what is immutability, the issues with immutability, how it's achieved in the blockchain context, and why. Here is a quick summary to basically summarize and put all of this together in a single nutshell. So in summary, new records keep the hash of previous block in a unique digital signature, and miners compete to find the signature of the next block. And that is new records. What is old records? Old records can basically be easily verified that previous blocks are correct, and this can be done so by hashing the blocks and checking that the nonces are correct itself. Let's now talk a little bit more about which. So, which examples actually show this property of immutability in the blockchain context? The first one is the ERC 721 standard. So ERC 721 tokens are actually used to emulate rare collectible items, and these tokens are non-fungible. So we spoke about fungibility, right? That when you have, say, like when I give you $1, you can pay me back by giving me the same $1 note on another $1 note. It makes no difference. But non fungibility basically means the opposite of this. Sorry? Yeah, sure, sure. I'll make that available as well. Yeah. Uh, it's more of some speaker knows that I take it down. Yeah. Okay. Okay. Oh, I see. Okay, yeah, that's why I actually prefer to make my slides very minimal in that sense. Like to only cover like certain points so that all the attention can be to the speaker himself. Yeah. So ERC 721 tokens are actually non-fungible, which means that every token is unique in its own way. So, okay, so that concludes the discussion on immutability. Now, before going to the third and the last property of traceability, I think I will answer any questions that all of you might have. So, are there any questions that you'd like to ask?
What happened after the under attack, right? Yeah, after that, I think they tried to do a fork, right?
Oh yeah, so they actually tried to do a fork. So that is one thing in which the entire the network was divided. So you had half the network which said that they wanted to fork and undo and reverse this famous hacker attack, and you had another half of the network who said that it's okay, we should live with the consequences of what just happened, and we'd continue with the loss of 70 million. And so because of that, there was a hard fork. So there are some people who are so that actually gave birth to what is known as Ethereum Classic. So actually, it's a very nice. The good thing that you brought it up. Hmm. Yeah. Yeah. Correct. Uh, so there has actually been some movement. So because there was still like there was a division in the network, and there were still people who would prefer to mine on Ethereum Classic. So there's still coins that are being mined on that as well. So it's still. Uh, so Bitcoin also they did have a fork at one point. Yeah. So that's also very interesting. So we do have two versions of Bitcoin as well. Yeah.
Every month they do a fork.
Yeah, that's another challenge of immutability. Like both of them. That's exactly what I said. So when someone launches an attack, you either live with the consequences because you can't change the data, or you have to fork, which is again going to be another issue that rises when we talk about immutability. Perfectly said.
Coin as soon as possible.
Yes, exactly. That's exactly. Okay.
So everybody sell their coin on the day. Even now.
Sorry.
Everybody can sell their coin now.
Yes.
Only that value.
Yes. 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 This is correct. It's correct. Okay. Uh, I have a couple of questions here, which with regards to the slides. So yes, I can try and share a copy of the slides with you. Just give me a second. Yes, so I have just shared with all of you a copy of the slides, so you can refer to that. And yes, so we are actually still on the same slide because I've kept my slides to cover just the overview of the content. So what I'll be explaining is actually going much beyond the slides. So yeah, so it is intended to stay and remain in the same slide actually. Hope that answers all queries. Are there any other questions with regards to the content or anything itself that you'd like to ask? So I'll pause and wait a bit at this stage and answer anything that comes up. So I think then if everyone's okay with what's happening so far, then we can move on to the next part of the conversation. So let me just quickly check if my screens are shared. Okay, so let's move on to the next and the final key feature of blockchain technology, which is the property of traceability. So here are another set of terms, two terms that I'd like you to be familiar with before we talk about traceability itself. The first term is an address. So what is an address? A blockchain address is actually similar to an email address. And so what this is actually used for is that it is used to receive and send transactions in the blockchain network. So every time you actually make a certain transaction on the network, so what gets recorded is that a person with this address made this transaction. So that is something that you need to be familiar with. Another term which I'd like to define before talking about traceability is I think something that all of you might have already heard about. And it is a term that is known as mining. So I'm pretty sure all of you would have heard about this term if you are familiar with Bitcoin or any cryptocurrency. But basically, mining is a process through which new cryptocurrencies are basically launched onto the market. So people or these so-called miners actually work with very powerful computers to solve complex mathematical problems to actually validate transactions. That is how the entire process of Bitcoin mining actually works. So this is the two terms that I'd like you to know about and take note of when we talk about traceability. So let's talk about traceability. So what is traceability? So there are two main aspects to traceability. The first aspect is the ability to hide links between transactions and addresses, which are important due to privacy concerns. And the second second point about traceability is that it is easy to match each transaction to the address on the blockchain. So you can actually match the transactions to the address quite easily through what is known as a block explorer. So in a block explorer, you can basically view any block. And what you can see through these explorers are you can see all the transactions that have been submitted and that are part of this block. You can see the miner who has mined this block. And you can also take a glimpse into the block structure itself. So I'd like you all to actually open Bitcoin's block explorer. So this is I've attached the link in this presentation, but all of you can easily access the Bitcoin block explorer on doing a simple Google search. So I want all of you to actually take some time, take a couple of minutes, and actually go to the explorer itself. So you can just go to this link, blockchain.com/explorer, or if you want, I'll also be taking you through what you can see over here myself. Basically, you can see what are the latest blocks that have been mined in the network. So you know that 11 minutes ago, a block of a certain height has been mined, and this is the size of this block. You know, these number of bytes. So you can actually take a look at each of these blocks. So if you go and you press this block, you can see the hash value of this block. So I spoke a little bit more about hashing functions, right? So if you give the data on this block as an input to a hashing function, this is the output that you're going to get. So this is the hash. Uh, the timestamp for which this block was mined is this. This is the block height. And even though it says the miner is unknown here, we don't know his physical identity, but we do know his address in the blockchain network. So if you can see the address of whoever actually mined this block in the Bitcoin network, but we don't know his physical identity. That's another property of traceability. That's another component or aspect to traceability that you can actually, completely dissociate the physical identity from the address of the miner from the digital identity. And you have other parameters such as the difficulty level or the Merkle root, the version, etc. And yeah, so this is something these are certain parameters and characteristics of the blockchain of each blockchain.
It's for 2 5 point.
Sorry.
How much the value of this block?
So the block itself,
Now 1 coin is 60,000.
yes.
So how much is this?
So the coin itself is different from a block. So the coin is so through mining you actually mint and create new coins. So this block is actually it's very hard to say what the actually it's not meaningful to say that this block has any certain value, but it is basically the coin that is produced on mining such blocks, which have the value of like 60,000 USD and all that you would mention. Right?
Because if you scroll down, you can see the BTC or BTC is
So this is the transaction volume. So basically in
coin like the for
Bitcoin, yeah. So it is the notation for Bitcoin itself.
What's supposed to be reward? Can I say that? Because you mine it, then you get 1 for 1.
Yes, that's perfect. Perfect. Exactly. So whoever mines this block actually gets a fee reward. So in order to incentivize the mining of the correct transactions, so whoever mined this block basically got 1.14 Bitcoin as a fee reward for each of the transactions that have been included. And the block reward that he gets is 6.25 Bitcoin. So for mining the block itself, he got 6.25 Bitcoin. Uh, so this is basically given to thank him for putting all this computational power into finding the solution for a computation complex mathematical problem. So that is the block reward. And fee rewards and transaction fee rewards. Suppose that I want my transaction to be included in this block, right? Now if I submit a transaction that has been included in this block, I now give the miner 1.14 Bitcoin to say that thank you for including my transaction into the block. Here is 1.15 Bitcoin that I give to you as a reward for that. Miner, yes, yeah,
So that's the guy who transacted each 1 for 1.
yes, exactly. That's perfect.
The guy who transacted.
Hmm.
So what is the nature of this transaction?
So these transactions,
Is it a buy and sell?
yeah, essentially everything boils down to buy and sell in the bit, at least in the Bitcoin protocol, since the main design objective is to facilitate these crypto transactions. Then you can say, yeah, it is more of a buying and selling type of region.
The transaction volume is 41,000, right? Times the 60,000 US dollars, which is about 12.8 trillion dollars.
Yes, exactly. So that is the so all the transactions that have happened. So they have this value of these many Bitcoin. And if you would like to find the US dollar equivalent, just like how you did the conversion rate, you can basically find how much these transactions, what the transaction volume in terms of US dollar is. So that's exactly what you did was exactly like correct, and you're right to say that.
So by now the Bitcoin is almost going to its 100% mine, right? Look out, 90%.
So we actually so the thing about the Bitcoin network is so to about the supply and demand, right? So one thing that they do is so they do have a cap and to basically limit the supply of Bitcoin. So what is actually done is that for every n like for a certain number of blocks that have been mined, the block reward now halves. So initially, if I'm not wrong, the block reward was 25, and now that half to 12.5, another halving happened to 6.25. So that is the supply and demand that you're probably referring to. Mm, yeah. So this is what you can see in the block explorer. But if you go back and if you so this is the block itself. Now, if you look at the transactions, right, the transaction also you can see. So you see one transaction just went through right now. That is on 2:27 a.m. Sorry, 2:27 p.m. Singapore time. This transaction just went through. The transaction was for these many bitcoins, and you can see the dollar equivalent that is written right next to it. And if you look at this, you can basically see the hash of this transaction, and you can see the addresses. So you can see that from this address to this address, the uh, the transaction was facilitated.
You see the exchange that the bank, the exchange that protected.
So the So this is the only proof that we can get. So if you see the status, right, it still says unconfirmed. So it's not completely confirmed that this transaction is being included and written in the blockchain. So this is a transaction request. So once the transaction has actually been included in the blockchain and it has been recorded in the ledger, then you can see that there will be a status change from unconfirmed to confirmed.
Because because February reserve one is no income what you call transaction going between and posted account
Ah, yes.
and posted means it's on the exchange. Unposted
Mm.
means you never go through
Mm.
maybe we can have wallet outside the exchange.
Yeah, basically. Yes, yes, exactly, exactly, correct. So yeah, so that is. So you can explore more about this block explorer yourself. But yeah, this is the point I was trying to kind of make. Yeah. This is the link to the block explorer. Okay, let me go back to my slides. So now let's talk a little bit more about traceability. So what are the issues that you face when you speak about traceability? So one of the problem with being traceable is that there is a lack of privacy. So I'm sure all of you are very familiar with the PDPA clauses and all of those. So it basically makes it impossible, or even if you look at the general data protection regulation. So due to due to traceability issues or privacy concerns, it would make it actually impossible to conduct full-fledged business over the blockchain. So the second issue is time. And so privacy schemes actually take much longer to compute, and this actually impacts the usability of the blockchain itself. We have made various solutions to target these specific problems, such as homomorphic encryption. But yeah, these two problems still exist and has not been completely 100% addressed. So now let's talk about why we would like, a blockchain system to be traceable. So if privacy, so basically now let's take a look at the two components and see why these two components of traceability is important. So if privacy is implemented, this could potentially give you better control over personal data. And also, one more key point is that information that actually requires a certain level of secrecy can actually be exchanged and conducted, and such data can be written onto blockchain networks. There is the privacy aspect of traceability, and the second aspect is being able to track the address on the blockchain. So, if records are basically meant to be traceable, this could give a better audit trail for provenance. Now, what is the meaning of audit trail for provenance? So it basically refers to the ability to be of being able to track the origins of say anything. So suppose you have suppose like how this translates in the food supply chain is that suppose you have in the supermarket an avocado that was mined at a certain you know farm in Cambodia. uh, being able to track the origins would mean that you can actually go back and see exactly where this avocado came from. So where was this avocado that you're eating farmed, and where was it actually grown? So that is the meaning of making for a greater audit trail for provenance. And the second point that I'd like to bring up here is that it also provides a fine analysis of the actions that have occurred over time by each peer, and thereby it also promotes a greater sense of like greater sense of transparency over the entire network. So that is another key point to keep in mind on how being traceable actually severely impacts your network for the good. And how do you make your transactions traceable? So your naive approach is for you to just put your name on the transaction itself and for you to be traced to it. So in some contexts, in some applications areas, people actually prefer to take this naive approach of traceability. But if you take a look at data science, and so such as work on analyzing decentralized exchanges makes it possible for transactions to be traceable. Now, how do you ensure transactions are untraceable? That's another aspect that we've spoken about, right? So now, how do you ensure that that your physical identity cannot be tracked by submitting blockchain transactions? So you have certain things called zero knowledge proofs, which let you prove that you know some secret to another party without revealing the secret itself. uh, in my opinion, zero knowledge proofs are really fascinating, and it's an entire field of study by itself. And it's really cool and fun to see how these zero knowledge proofs work. But basically, it allows you to prove to a certain party that you know some secret, and you don't have to reveal the secret itself in that process. So that is the meaning of zero knowledge proofs. Now, which application areas actually use traceability? So, a key application area is the application in the food, not only the food, but more generally the supply chain industry. So, supply chains actually contain complex networks of suppliers, manufacturers, distributors, auditors, retailers, and many stakeholders. And basically, a blockchain shared IT infrastructure can actually help streamline the entire workflow of how these parties interact and what the information flow throughout the supply chain would look like. A shared infrastructure would also provide auditors with greater visibility into participants' activities across the value chain. So this is another key application. If you talk about which applications actually make use of traceability, the key word that pops up is the supply chain industry. And traceability also improves operational efficiency by mapping and visualizing enterprise supply chains. So yeah, that is what we can say when we reflect and think back about which applications areas actually use traceability. Okay, so that basically covers the fundamental three key features of blockchain. So just to take a quick recap. So the three features are decentralization, immutability, and traceability. And what makes a blockchain unique is that you have these three key features come together in a single system. So that is the unique value proposition of blockchain technology. To have decentralization, immutability, traceability, all three converging into a single system. And that is what gives blockchain technology the power that it has today. So at this point in time, I'd like to stop for a quick break, maybe a 10 to 15-minute break, because there's been a lot of content that we've covered right now, and it may take some time for you to process all of this. And so right now, the time according to my system is 2:36. So we will be back sharp at 2:46 and continue to the next section of this workshop. Thank you. Okay, I hope all of you uh, uh, had a nice break and got a bottle of like a gulp of water, a breath of fresh air, and all of that. So we'll be starting back our session and continuing the conversation and the workshop that we've been having. And the next section I'd like to talk a little bit more about are the different blockchain protocols. So I think everyone is very familiar with cloud services and cloud technology, cloud-based technology, and so you all know that there are various different cloud platforms that are out there. Like you have Microsoft Azure services, you have the Google Cloud, you have Alibaba Cloud. Alibaba has its own cloud platform, and so you have all these different cloud platforms. And similar to that, we don't have a single blockchain, but we can have various different blockchain protocols. Now, each of these blockchain protocols actually have a very specific design objective, and their network type and their network architecture is also in line with this design objective. So, the three most common blockchain protocols that we have and that we'd like to talk about today are the Bitcoin, Ethereum, and Hyperledger Fabric protocol. So the Bitcoin protocol is probably the most famous blockchain protocol that almost everyone would have heard about. So what is the Bitcoin protocol? So and what is the design objective of the Bitcoin protocol? So Bitcoin was actually devised and it was the first main application of blockchain technology, and its basic objective was to allow cryptographic or cryptocurrency payments over a decentralized network. So that is the main design objective of the Bitcoin protocol. And so today we know that the price of Bitcoin is like an all-time high of like 60K US dollars and all that. And so Bitcoin is starting to gain a lot of traction of it. But yeah, basically in its origins, if we go and we think back about why Bitcoin was formed, it was to allow crypto payment transactions over a decentralized network. So what is the network type of Bitcoin? So Bitcoin network is actually a public and permissionless network. So, as the name suggests, public and permissionless networks are those networks where anyone can join the network without needing permission from anybody. So, suppose today you wanted to go and mine Bitcoin of your own, right? No one is stopping you. There are no barriers of entry, and no one's going to stop you, and no one's going to deny you your right to mine Bitcoin. Similarly, the second biggest cryptocurrency by market value is Ethereum. But if you take a look at Ethereum and what is the main purpose that Ethereum is trying to serve, is that it is actually trying to provide a platform for developers to launch their decentralized applications. So it's not like Bitcoin. Bitcoin is basically for crypto payments, but Ethereum wants to do something different. So they want to give you a platform to launch your decentralized applications. Suppose, like I basically spoke about the parallels between a database and a blockchain, right? So you can essentially store and retrieve data from the blockchain. So Ethereum's main uh, aim is to become the world's computer, which means that it wants all its applications to be powered by the Ethereum protocol, where all these applications can basically store data and receive data from the Ethereum blockchain. So that is the main design objective of Ethereum. And the network type for Ethereum is again public and permissionless, which means that tomorrow, if I want to join the Ethereum network and start building applications on the network, or if you want to do so, no one's going to stop us. The third protocol I'd like to talk a little bit more about is the Hyperledger Fabric protocol. So the design objective of this is quite similar to Ethereum, but the key word here that I'd like to talk about is that these applications, right, these decentralized applications need to have a focus on privacy. So that is what matters. So they have a focus on privacy. So, in line with the design objective, the network type of the Hyperledger Fabric protocol is designed to be permission, which means that only entities which are trusted by the organization can join the network. It makes sense, right? Suppose you have data that is somewhat confidential to only certain individuals within an organization, or which is only confidential to people who belong to that organization. You don't want any public entity to join the network and to be able to read such data. And so that's why the Hyperledger Fabric protocol is actually, or rather than reading such data, you would not want them to basically have access uh, uh, have the ability to submit transactions on the blockchain protocol itself. And so that is why the Hyperledger Fabric protocol is actually permissioned. Since we are like most of us are actually based of Singapore here, I felt that there is a need to actually mention another protocol that has actually is up and coming, which is known as the Zilliqa protocol. Zilliqa is actually a project that was started in the National University of Singapore by a bunch of researchers and professors and people across various disciplines. And so the Zilliqa network is actually up and running and live today. So that's another protocol that you can read more about. But the main value proposition of Zilliqa is that they were the first network to implement sharding successfully, and basically they used a Byzantine fault tolerance approach to consensus rather than your standard proof of work, proof of stake, to increase your transaction speeds. So these are the main blockchain protocols that are out there, and I will leave it up to you to basically read a little bit more about the Zilliqa protocol itself. But I think it is definitely important for you to know about it and take note of it because it's an up and coming protocol, and it's actually gained a lot of traction throughout the years. Okay, with that, that basically concludes the section on the the different blockchain protocols. And now I'd like to talk a little bit more about smart contracts. So, what are smart contracts? So behind every application, the decentralized application that is powered in the blockchain, in the backend system, you have these smart contracts which are deployed, which basically are the building blocks of all these applications. So what is a smart contract? So a smart contract is actually a computer protocol which is intended to digitally facilitate, verify, or enforce the negotiations or performance of a contract. There is a very official textbook definition of what a smart contract is. So, but what this essentially means is that suppose today person A and person B, or you and me, have some sort of a contract, would like to draft a certain contract to say that okay, if these certain criteria are met, then this is what we are going to agree upon doing. Like suppose if you have like a rental agreement, right? So you can say that if I become a tenant of your house, I will pay your rental fees uh, regularly at this on this day every month, and this is the amount of rental charges that I'll pay you. So such contracts. Suppose we have such contracts. So i unlike traditional contracts, smart contracts actually allow for the automatic facilitation, verification, and enforcement of such negotiations, and all of this is actually achieved through a computer protocol. So how this happens is that once certain terms of the contracts have been fulfilled by the parties, the smart contracts will actually self-execute. So which means that the clauses and the data of the smart contract will actually have to be digitally programmed and fed into the blockchain by a trusted third party, which is known as an oracle. So if you take a look at how these smart contracts work, these are basically the four steps involved in execution of a smart contract. So the first step is for a contract to be written as a code into the blockchain, where you have to specifically hard code and encode the various clauses and data. So an event, which can basically be in the form of, say, a delivery of a good or an expiration date, or any event can basically trigger the smart contract, and the execution of the code of the terms and conditions that have been encoded into the contract will now happen automatically. And so when this is done, the assets are basically released to the necessary parties if the contract involves certain financial transactions to take place. And finally, regulators can study the immutable transaction record and understand all the activity that has taken place and has been recorded into the sample-proof distributed blockchain system. Now, the beauty of the decentralized nature of blockchain allows the smart contract to actually bypass the middleman. And so traditionally we see that enforcement of contracts heavily depend on a middleman. So if you look at various contracts that that we can think of, various examples of contracts and agreements that various parties have come to, we see that they are generally individuals or institutions such as banks and solicitors, which actually are required to facilitate uh, these binding contracts in a legal manner. So it actually requires a middleman. But these smart contracts, right? You can see in these steps, you actually don't need any middleman, and you can completely bypass the middleman in this entire process. So now, why is this important? This is important because generally having a middleman enforce, the terms of the contract would basically mean that the contract will take a longer time to execute, and more importantly, this middleman can basically be biased towards a certain party. But let's talk a little bit more in detail of the benefits of these smart contracts. So these smart contracts, in a nutshell, have the benefits of autonomy, security, faster speeds, increased accuracy, cost saving, trust, and backup. So, what is the benefit of smart contracts if you look at autonomy? So, the decentralized nature of these blockchain contracts and me so basically help you fight free from the middleman and fight free from centralized institutions, and that is how you gain autonomy through smart contracts. Smart contracts are more secure because uh, because blockchain systems are tamper proof and are unalterable. So these ledgers are completely 100% tamper proof, and so this and also provides a definitive proof of all the transactions that have actually been recorded and that have been taken place using this ledger. So it also relies heavily on encryption, and so this essentially creates an ecosystem that facilitates very secure peer-to-peer transactions. So that is a key benefit of smart contracts, more secure. Another key benefit of smart contracts is that it allows for faster speeds. So when you completely bypass a middleman, right, you basically reduce on the time that is wasted in having the contract uh, verified or having the terms of the contract verified by another party. So suppose you have a court date to basically say that, okay, this person has defaulted from the agreement that we have reached when we signed this contract. You can have a court date which is set months after you file a complaint, years after you file a complaint in some cases, and so a lot of time is actually wasted. So a smart contract allows for faster speeds, and by bypassing the middleman, you actually prevent the wasting of a lot of time. It also allows for increased accuracies, as humans tend to make mistakes and humans tend to be biased. So when you have a human middleman, like it is quite common that he may be biased, he may make some mistake, and so because of which the contract cannot be enforced correctly. But through increased with accuracies and smart contracts, you can basically ensure that the contracts are executed perfectly. Smart contracts also help save a lot of cost, and it also increases trust in the network, as unalterable ledgers mean transactions are essentially set in stone. And also, one more benefit about smart contracts are since they are based on the blockchain, you have effectively a backup. So data storage devices can basically fail, and you have what is known as a single point of failure problem. This is exactly what the blockchain technology tries to eliminate completely. But however, smart contracts actually duplicate all transactions so that all parties have a record of all the transactions that have been submitted. So the likelihood of all parties having to suffer, you know, data storage failures is practically zero or practically non-existent. So these are the main benefits of smart contract. But if you really take a step back and reflect on all the benefits that I just listed down, you'll realize something. You'll actually realize that all these benefits and all these application areas are based on the three key properties that we've spoken about. There is immutability, traceability, and decentralization. All the advantages. And so, yeah, so like I said, there is having the three properties come together in a common platform is the main unique value proposition for blockchain itself. Now, let's talk a little bit more about the limitation to smart contracts. The main limitation that I'd like to shed some light upon is the legal adjustications in enforceability. So traditionally, right, so the establishment of a valid contract covers various constructs such as offered by one party or parties, acceptance by the other party or parties, a promise, some sort of a consideration, and also legal capacity mutuality in some contracts. So some elements are actually not applicable to smart contracts, and therefore regulations actually need to come up with a new set of enforcements that can prove smart contracts to be valid. So that is the main problem that we face with smart contracts. It is legal adjustications and enforceability. There's actually a paper that I'd like you all to read a little bit more about. Let me just quickly give you the link for this paper itself. It's again on smart contracts and the implementations and the applications and all that. And I covered so most of the content actually comes from this paper, but I'd like all of you to also try and cover the content and read a little bit more on your free time. So let me just add the link to that paper right here. You have all received a link by now. So that's again something that you can keep in mind, and a paper that you can kind of explore on your own. So that is basically an introduction to smart contracts. So let me now take some time to talk about blockchain decision models. But before that, I realized there's a section on smart contracts that I'd forgotten to cover, and I'd like to cover a little bit more about, which is basically the application of smart contracts. So I'll basically be talking about the application of smart contracts in three key industries. There is the financial industry, healthcare industry, and the music industry. So the first one is, of course, the finance industry. So smart contracts are actually gaining the most transaction in the finance industry, and many financial institutions are actually trying to adopt blockchain and smart contracts to simplify and digitize the entire process. So some examples are actually that I can think of maybe at the top of my head is to do with this bank UBS. So it's actually recently adopted the use of blockchain and smart contracts to create some sort of a self-paying instrument. And this self-paying instrument is designed in such a way that it will be entirely risk-free, and it is an available payment stream for unbanked people. So that is a key application area of smart contracts. That is financial industry, and actually these kind of micro contracts can actually allow for what is known as microfinancing in the finance industry, and this can basically give the ability for every common man to pay for everyday goods. An application area of smart contracts in the healthcare industry basically tries and targets the various problems that the industry faces in terms of data conservation and patient privacy. So when you have a smart contract, the middleman can essentially be completely eliminated. So if we take a look at a specific example, so earlier this year I was reading a little bit more about this decentralized application called uh, Applicature, if I'm not wrong. Yeah, Applicature should be its name. Yeah. So Applicature basically is a blockchain development application which was basically powered entirely through smart contracts. And the main thing that this application aims to do is that it aims to foster data integrity, transparency, and secure record of patients' data health. So that is basically what they were trying to do, and that is the purpose that this application tries to solve. This is another glimpse into what how smart contracts can be used in another industry, specifically the healthcare industry. And finally, let's talk a little bit more about its use case in the music industry. So earlier this year, I was reading, or rather last year, I was reading more about a music streaming platform which actually decentralizes revenue and has a proper allocation of revenue streams to respective artists. So one of the key problems and key challenges that the music industry is plagued with today is that revenues actually fail to reach the content creators, and this is entirely due to centralization. So suppose you have various agents, and you have lot of uh, so suppose I'm say like a guitarist or like a musician who would like to release a record album or would like to release some songs to the public. I would have to go through an agent to actually do so. And because of this middleman, there is an entire lack of transparency. And this transparency is actually a dispute over ownership of content. And so it also there's also very little visibility on the royalties payment. And so essentially the all the process that happen pertaining to like payments and fulfillments of obligations on like royalty payment and revenue payment and all of that is done so in a very siloed manner, in a very not open to public, a very opaque platform. So the transparency is what is missing. And so through the help of smart contracts, what you can essentially do is that you can allow the validation of the ownership of a song to happen through a transparent tagging system. So what this implies is that the party who creates the tracks can get the right portion of fees allocated from royalties by releasing the track. Yeah. So these are some of the very few examples of the real world challenges and the real world the problems that these industries and these businesses have faced, which can actually be completely solved through smart contracts and through blockchain technology. I'm sure there are a lot more examples that you can find uh, if you go and do a simple Google search, if you read the paper that I linked previously. But these are some of just a glimpse into the potential of smart contracts and just how powerful they can be used, how powerfully they can be used in the industry today. Okay, now let's talk about blockchain decision models. So let's take a step back and see exactly everything that we've covered and go over a recap of whatever we've done. So first, we've actually spoken about the three key properties of blockchain technology. That is decentralization, immutability, and flexibility. So that was part one of the workshop. And the part two of this workshop was basically talking about smart contracts. And that is in various blockchain protocols. What are the blockchain protocols that we have and smart contracts? And now we are reaching the final section and probably the most interesting section of the workshop. And that section is how to use blockchain and how to come up with blockchain solutions and also examples of various blockchain solutions. So this is the more business aspect of blockchain. And now we're actually going to look at some case studies, some use cases, and see when will you use blockchain solutions and what are some of the examples of blockchain solutions that are being deployed today in the industry. So before we actually talk about the case studies and some use cases, we need to talk a little bit more about blockchain decision models. So this model that you see in your screen right here is a decision model that is being devised by IBM. So what is a decision model? So a decision model is actually a formal system which is used for perceiving, organizing, and managing the entire business logic. And these business logics are basically the why of why you make certain business decisions. So this is the underlying this is the underlying logic behind why a certain organization would like to make a certain decision. So this is the IBM model, like I mentioned, and now we basically break down this entire model to actually evaluate whether or not you should use a blockchain solution for a particular problem that you are facing. So this model is actually quite big. So you have various inputs. You have to answer various questions. Say yes, no, yes, no, yes, no, and we'll finally come to a final state of yes, you should use blockchain, or no, you should consider alternative approaches. This is a little hard to keep track of, but it can basically the entire model can boil down to these three key ideas. So the three key ideas that this model tries to encapsulate is that a blockchain would be a possible solution for a problem that is number one, involving contractual agreements and complex business logics. So if you look here, right, look at all the questions that it asks. One thing that you can basically see throughout all, one thing that is consistent that you can see throughout all the questions that is asked is that it basically tries to identify whether you involve contractual agreements and whether you make use of complex business logics. And so, why will blockchain solution be a proper, or rather a perfect solution to solve such problems? Is that the property of immutability of blockchain comes in handy to basically ensure that contracts and other legal documents are entirely tamper-proof. So, through smart contracts and immutability of the blockchain, you know that these contracts that you basically use and these agreements that you come up with and these legal documents that are associated with them are completely tamper-proof. And these smart contracts essentially provide more security when compared to traditional contract laws. And it also reduces the transactional costs associated with contracting. Because today, if I want to go and draft a contract and get the legal structure in place and get it formally verified and all that, and then go through the formal drafting process, I'm going to spend a lot of money. And all this money is so this is a potential opportunity to save costs in organizations. So now the organization, suppose they can use smart contracts, which can effectively get the job done for a lesser cost, it is definitely much preferred, over your traditional solutions that basically take up a lot of money. The second point that this model tries and encapsulates is that suppose you require your transaction to be private, so you can ask, you can see here, like they ask for you need to keep your transactions private. So yeah, so suppose your problem requires you to keep your transactions private, then blockchain solutions are perfect. And why are blockchain solutions perfect? Is because of the key property of traceability that we spoke about before. So the property of traceability and the privacy that is associated with it allows you to keep your addresses in your blockchain network completely separate from any physical identity. So any physical identity cannot be traced back from your address. And that is what we spoke about during traceability. And because of this, uh, blockchain solutions can be perfect for problems that require your transactions to be private. And another question that this model basically asks you, and this model deals with, is whether your problem requires a market approach. So, if your problem does require a market approach, so this point can basically be broken down, and you can consider three other factors before actually deciding to adopt a blockchain solution. And what are these three other factors? First factor, whether the potential use case requires greater than two parties or more than two parties to collaborate. If the answer is yes, then a blockchain solution can definitely come in handy, since decentralized networks essentially give participants the flexibility to create your own customized solutions using proprietary logic while still keeping it running in a common distributed ledger. That is one factor. The second factor, does your potential adopter want to lower his costs? If the answer is yes, then once again a blockchain solution comes in handy. This is because deploying a blockchain solution can help reduce a lot of overhead expenditure. And this can significantly lower transaction costs since cryptocurrency payments are handled in a peer to peer network without any centralized authority. So this basically translates into lower merchant processing. And this is essentially what I spoke about a little earlier also, but I think it's more appropriate to mention that point here when we talk about your solution requiring a market approach. And the third point is whether it is important that discoverability is improved. So if your problem is such a problem that you would like to improve discoverability, then yes, blockchain is perfect. So this can essentially be done through a solution that makes use of blockchain technology, since every peer in the decentralized network has access to the same ledger. So it's not that I have a different copy of the ledger or you have a different copy of the ledger, but everyone has a copy of the same ledger, and it is very easy to broadcast an intention to basically submit a transaction or to retrieve data from a transaction. So that is basically what IBM suggests you to. This is the thought process IBM suggests you to follow while deciding whether or not you would like to adopt blockchain solution. So yeah, so we can try and follow the business map. It's not too difficult, but yeah, I've kind of broken it down and basically explained the key points that this thing tries to encapsulate. Okay, so now that we know how to evaluate whether or not we should use a blockchain solution for a given problem, it is time for us to actually look at various solutions and various problems that are being solved by blockchain today. So I think I have a lot of time in my hands actually. Uh, this is still 3:18, and I just have two more slides to cover, and just two more case studies to analyze on various blockchain use cases. So whatever time is remaining, I will basically open the floor up to Q&A, where you can ask me any questions that you have in the session, and we can basically have a free flow conversation. So now let's take a look at various blockchain use cases. But before proceeding, I'd like to again ask you if any of you have any questions that you'd like to ask me. If so, then now is the best time to bring it up. Yeah, probably give it another few minutes. I hope all of you are able to follow. If all of you are able to follow, can you please raise your hand so that I know that you know that I'm not just speaking to a wall. And yeah, wonderful. Okay, I'm getting some responses. That's great. Okay, so I think if everything is good, then let me move on to the next sections of this workshop. Okay, now we're going to specifically study two case studies, and both of these are blockchain projects. And the first one, the first use case that we'll be studying is the use case in the supply chain industry, and we'll be doing so by looking at an example of a startup called Demuto, which basically leverages on blockchain technology to provide solutions for food traceability in the entire supply chain. And then we'd be going over a case study on how blockchain can be used to verify, to provide tamper-proof certificates. And we'll be looking at a project called Open Search, which is being spearheaded here in Singapore to kind of do so. So let me, so before I play the video, let me just make sure that I'm sharing my screen with audio enabled. So let me just start resharing my screen. Yeah, so you should now be able to see my screen and hear any audio that I play also. So let's have a look at the first case study. That is the case study in supply chain by looking at a startup, Demuto.
Food is perhaps the oldest industry in the world. Most of us take our food for granted. the world. Most of us take our food for granted, and they don't realize that it's actually an industry plagued by two massive problems: sustainability and safety. About 600 million people fall ill after eating contaminated food in a year, and of which 420,000 people die in a year. Now, the number of food waste is even more staggering, and it's about 1.6 billion tons of food waste a year, and this translates to actually $1 trillion worth in market value. Hi, my name is Gary, and I'm the founder of Demuto. Now, with this many problems that plague the industry on a global scale, Demuto aims to solve this problem by tackling it at its source, and that is to create visibility and traceability of data across the whole supply chain. We believe that blockchain can help secure the future of our food. This problem has plagued this industry from farmers to distributors and everyone is because everybody works in a siloed environment. So when you receive something and either have quality issues or even suspect safety issues, you're not able to go back into various stakeholders' ERP. So how do we solve this problem? It's really using blockchain. And this is where the blockchain technology really comes in, where the custody of truth is now providing us the ability to put into a database where everyone can share that information. And when we are able to share this information, we are able to pinpoint the source of the problem and also know where it happened along the supply chain. From the point of taking the fruit from the trees and then getting it to the harvesters, it goes into the packaging. The first stage of digitization happens at the packing house, where the image of the fruit is captured onto a QR code and it's tagged into the carton box, which has a unique QR code. That means each and every box will have its own unique identity. Now, this is what we call digital asset creation, and this is the IoT device which we call DACI. And this digital information that has been captured all now passed into our platform. With the fruit and the carton box captured, we now can associate it to the pallet that now goes into the container, together with the details of the purchase order and all the documentation and specification. Now, from the buyer and receiver perspective, now they only download our DACI application, where they can now scan that QR code of the carton box and now provide the feedback. Now, all this information is now captured, so this will allow the stakeholders to access information various touchpoints along the supply chain. And it's more importantly also allowing the consumer to now scan the information to be able to now see where it's formed and to actually know whether it's actually safe and all the requirements that's already been done. But what is most important is to allow them to have a feedback loop where you can now actually feedback what you feel about the food, whether it's a 5-star or even a 1-star. So that we actually now have information between the consumer and the farmer. And for the consumer, now you know where your food came from, whether it's safe and it's produced responsibly. It really is about making sure that once we trace and we track the data that we have, it's really being able to be transparent for all. And this would then allow us to tackle the many problems that are actually plaguing this industry from the farm all the way to this system that we've built. We've been able to really impact the ecosystem. And what it really has been able to do is at the farm level, we've been able to trace, track, and then build it on a platform that is transparent, and therefore we can actually now build trust. One of the impacts that we actually kind of proud of is the Morning Glory example of a small farm with his family picking up farm, sweet corn, and spaghetti squash. In a situation like this, we'll be able to empower even a small farm to be able to put their items on the blockchain, to be able to digitize the information that they have, to be able to now send it from logistics to the receiver side, and the receiver side in this case is actually a small retailer, Ryan Grocer, and this is exciting because even a small grocer like Ryan Grocer is able to now share that story about where this information or this produce actually came from, to now be able to share with their consumer. One of the partners we have been working with is PwC, and this is to ensure that the framework of trust is built, and we can audit and third-party check to ensure its reliability and validity. The other party we have been working with is IBM, and through this collaboration, we're integrating our Demuto technology seamlessly into the IBM, which is actually IBM's blockchain-based solution. Now, What we have done is to basically come on board to level the playing field for even the smaller pack houses in the supply chain. And this will facilitate getting smaller pack houses and suppliers connected into the big highways that the IDMs have built. And this will really enlarge our ecosystem. We think this is where the change should happen. And we want to see a lot more successful collaboration in the landscape. We want to break down the barriers and allow more people to come on board to innovate and develop future-proof solutions for this industry.
Okay, so I hope you all enjoyed the video that I just played. I found it to be quite informative the first time I saw it, and basically it shed some light into the challenges that the supply chain industry faces and how blockchain solutions can actually be used to overcome these challenges. So let's actually take a step back and analyze this video a little bit more and actually see what are some of the key information that we can derive from this video are. So for this case study in the next, basically I'll talk about four things. Firstly, the problem that this industry faces. Secondly, the current solutions that have been set in place to overcome these challenges. The third thing would be about the problems with these current solutions and why blockchain will do a much better job. And finally, I'll talk about the challenges of implementation of a blockchain solution to target each of these problems. So I'll start with the first one. So the overlying theme of this video was food safety and regulation. So what is the problem? So the problem is that food safety is actually a very growing concern among various consumers and regulators. So if you listen closely to the video, so the person had actually given some statistics. And so on doing some Google search and doing some analysis, I found out that according to the World Health Organization, there was an estimated number of 420,000 people who died in just 1 year as a result of food contamination. So what this effectively means is that everywhere in the world, every 1 in 10 individuals are actually victims of fatalities due to foodborne illnesses. So this is actually a very, very growing concern because 420,000 is not a small number. It is definitely a very, very significant enough number for us to consider this a large scale problem. Another part of this problem was that food safety breaches also resulted in close to $110 million, sorry, not million, $1 billion, which have been lost annually because of the wastage of close to 1.3 billion tons of food. This is a crazy high amount, and definitely this problem is something that really needs to be solved, and something that the supply chain a solution and solution to this problem will largely benefit the entire supply chain industry. So if we take a look at the current solutions, the non-blockchain solutions which have been put in place, so the main solutions revolve around regulators in the United States and other countries who have worked towards improving food safety measures by by implementing various acts such as the Food Safety and Modernization Act. And what these acts basically try and do is that they try to increase control and preventive measures on food imports, and they basically impose preventive measures on food imports. So that is the solution that's currently there. They just try to improve regulation and increase the control that you have on approving food imports. Now, what is the current what are the problems with the current solution? Why isn't this solution comprehensive enough to completely solve the problem? So while placing regulations is like, well, it does try and solve the problem to some extent, but it's not attacking the problem and the main pain point that an ideal solution would try and address. The main pain point that an ideal solution would try and address is the lack of transparency and traceability in the entire food supply chain. So this is the key pain point. And unfortunately, just placing regulations is not targeting this pain point in any way. So, despite having a highly regulated system, there are still large chances of contaminated food entering the supply chain. And in order to prevent any breakout and to prevent these 420,000 deaths due to foodborne illnesses, it is very, very essential to pinpoint the exact source of contamination. And that is exactly what an ideal solution would try and do. So now let us enter blockchain and talk about why blockchain might be a potential solution for this problem. So traceability is one of the key features of blockchain technology as we've spoken about, and it also enables it to be a perfect solution for the current problem. How exactly is traceability going to allow us to solve this problem? So basically, it will enable us to have the ability to quickly pinpoint the source of contamination, and it basically gives us the ability to fight against these food outbreaks. Fraud prevention is also another added benefit that traceability and blockchain brings together. What are some of the challenges of implementation of a blockchain solution in such a context? So, key problem that blockchain solution faces in today's work is today's world when we look at implementation is the challenge of the blockchain system being as reliable on only as much as the data that goes into it is. So the reliability of the data that goes into the blockchain solution entirely determines how reliable a blockchain solution actually is. This is commonly known to the common man as the garbage in, garbage out problem, where if your data that is actually being stored on the blockchain is not, it is not true, or there are problems with the data that is being stored in the blockchain, so that is going to translate into problems on the solution as a whole. If you put garbage into the blockchain, when you try and retrieve data from the blockchain, all you're going to get is garbage. That is the garbage in, garbage out problem. So the blockchain's key unique value proposition of creating an immutable record of transactions that can only be changed with consensus of other parties in the network is only as good, it's only effective if you can ensure that the data that is attached to the packet of, say, long guns in a grocery store is actually accurate and is perfect. And the person recording this data doesn't make any mistake. So that is the key challenge of implementation when we talk about a blockchain solution for the supply chain industry. Let's now move on to the second use case and the second case study that is on how blockchain solutions can be used to create a verifiable certification. And for this, I'll be playing a video on Open Search, which is a blockchain project that is being driven in Singapore right here.
Meet Thomas.
Meet Thomas.
He recently
He
graduated from
graduated
Polytechnic and is looking forward to start his career. This does not mark the end of his learning journey, but the beginning of lifelong learning. Throughout his career, Thomas will be attending numerous courses, receiving numerous skills certifications. All these certificates, combined with secondary and tertiary certificates, can be difficult to track and manage. Searching for certificates and getting them notarized takes time and costs money. Introducing Project OpenSearch. When Thomas graduates from Poly, he receives an email with a link to his digital search. This digital search will also be automatically loaded in his skills passport on his MySkills Future account. Here, he can get recommendations for courses to continue on his lifelong learning journey. Certificates are secured in his MySkills Future account, and new certificates can be imported easily. Now, when an employer asks for his certs, he can easily download them from the MySkills Future portal or share them via the mobile. When the employer receives the digital search, he opens a browser and goes to the OpenSearch website to drop each search, and voila, it's verified. So simple. All your certs in one place. No need for physical certified true copies. Simplify the verification process. Project open source. Simple, secure, seamless.
Okay, wonderful. So when I first saw this video, I found the concept of using blockchain solutions for like verifiable certification to be super cool and super interesting. So let's now take a step back once again and do a thorough analysis of this case study also. I'll again be similarly talking about the problem that we're dealing with, the current solution, how blockchain can basically help address this problem, and also the challenges of implementation of a blockchain solution. So if you take a look at this problem that this video kind of hinted at and kind of described for us, the problem can be thought of as as two pronged. So the first aspect of the problem is that the issuing of a lot of counterfeit certificates actually exist in reality, and there are actually a lot of counterfeit certificates that are being passed down and that are in circulation today. So what is a counterfeit certificate? Suppose that I'm a student who actually did not study in SUTD. I can actually create a fake certificate with some fake credentials saying that I studied in SUTD from this year to this year, and this is the degree that I got. And I can show this to an employer and basically saying, see, I'll have a degree. Now you can employ me and take me into your organization. So that is the problem, the first aspect of the problem that open source is trying to tackle. So this actually has a lot of disastrous implications. So just imagine a situation where a surgeon who's hired to perform surgery on you actually does not have the required credentials to be present in the surgery room and to be present in that operation theater, and instead made his way to the operation theater only through counterfeit certification. So you can just think about how scary, such an issue is, and the potentially disastrous implications that such problems will give rise to. The second aspect of the problem is that the verifying of a large number of certificates is actually very lengthy and happens in a very painstaking process. So the entire process of certificate notarization is very lengthy. It involves a lot of checks and balances, and it involves going through a lot of people and a lot of processes, and so this entire process is very painstaking and also consumes a lot of time. So anyway, uh, let's now talk about how the current solutions which are actually being put in place to address this problem. So surprisingly, before a blockchain solution was adopted, there was no solution that was put in place for such an issue. So we do have traditional notary services which are basically used to kind of establish authenticity of certificates, but there was no digital and standardized way to track and manage these accomplishments. And so in short, there was simply no solution to the specific problems that open source is trying to solve. Let's now talk about enter blockchain. So the blockchain can be used to provide an automated platform for certificate and credential verification, as its key features are: number one, the ability to prevent counterfeit certification by being issued, by ensuring that all certificates are basically validated and vetted through a tamper-proof system based on immutability and transparency. That is the first key aspect. The second key aspect is that the entire process of validation of a certificate can now be seriously shortened, as the current solutions can just involve the pushing of transaction into a blockchain rather than making it go through a centralized authority or a middleman who has to oversee the entire process and who has a very limited capacity. So this is how blockchain can actually be used to tackle this problem, and this is a solution that it can bring, that it can use to bring about change in the entire system. What are the challenges of implementation of such a solution? So the main implementational challenge of a blockchain solution for this specific use case of this specific problem is that completely new systems give rise to a lot of difficulty in transitioning from legacy structures in organizations that have grown used to implementing a conventional system. So what this essentially means is that all these institutions which basically are to use a blockchain system to effectively verify their transaction will find it very hard to transition from the existing system, as these systems are legacy systems and have been set in place long ago and have been in use for a very very long time now. So there will be a barrier when it comes to adoption, and so it's all about how can we simplify this barrier and how can we enable adoption to happen much easier, and for this entire process to happen a lot more seamlessly. So that is it about the second case study and how blockchain can be used to provide tamper-proof certificates and for validating credentials of the certificates which are basically in circulation today. So with that, I thank you all for joining me for today's workshop. It was a pleasure to have you all. That concludes my session, and that's basically all the content that I'd like to share with you. But before we wrap up, I'd quickly like to summarize everything that we discussed. So this workshop basically had three parts: part one, part two, part three. So in the first part, we spoke about decentralization, immutability, and traceability, which are the key foundational properties that make blockchain powerful and make blockchain what it is today. We then went on to talk a little bit more about uh, the various blockchain protocols which are in use and what a smart contract effectively is. And we finally concluded the session by talking a little bit more about blockchain decision models, which help you decide for what problems a blockchain solution is perfect. And we also deep dived a little bit more into existing use cases and case studies of blockchain solutions which are in the market today. So with that, I conclude all the content that I'd like to cover, and I'd like to open up the floor for any questions that you'd like to ask me, which I'd be more than happy to answer. I'll just quickly shift back to the Fosasia chat also to see if anyone would like to ask any questions there. And I'd also like to take this chance to, for all our physical attendees, I'd like to take this chance to personally get to know a little bit more about what you felt about this workshop, and also hope to answer any questions that you might have, and anything that you might like to ask. But before that, there is another opportunity that I'd like to share with all of you. Okay, I hope my screen is visible now. You can all see my screen, right? So I'd like to talk a little bit more about the skills future. So are you looking to upgrade your skills for a career progression or transition, but are you not aware where to start? Then what you can do is you can speak with Skill Futures Singapore's skills ambassador. They will help you identify the skills needed and gaps, and help you gain useful tips and advice on how to kickstart your skills search. Scan this QR code and explore more. This is the QR code that you can scan to get in touch with Skill Future Singapore's skills ambassador. I'll give you 5 minutes to scan this QR code. Okay, not 5 minutes. 5 minutes is a bit too much. I'll give you another minute to scan this QR code. But in case you're not able to get it, no worries. All the other workshop attendees and participants will also have these slides showing up on your screen, and you can catch it then also. Okay. And your feedback is also very valued by us. So we'd definitely like you to share your experience and feedback with us. So please scan the first QR code and share with us what you felt about this workshop, how can we potentially improve going forward, and what you liked about the workshop, if you did like it and if you did enjoy it. And you can also find out more about the wide range of training courses and resources at My Skills Future portal, which you can access by scanning the second QR code. I will leave this flashing for next few minutes, and after that, I'll basically spend all my time answering any questions that you have and going table to table and getting to know you guys better also.